Wow, I hadn't seen this room before. This is nice. Hello. It would be funny if I had shivers as a speaker, but not as an MC, would it? So just in case you haven't had enough of me, here I am for 20 minutes. Let's see if you can stand it. So having fun with ES proxies, who am I, yada, 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 yada. You'll see that on the slides at the end, and she said it. This is the owner's manual for the slides. The link is at the end. You'll get that. So, ES proxies, what is it? Well, they're awesome. And that's it. If I were an AI vendor, I wouldn't have to say anything more, and I'd get millions. But I'm not, so what are ES proxies? They are not network proxies, right? They are really proxies in the OOP sense. So they're an intermediate between an actual object and whoever interacts with it in your program. So they're basically a wrapper around an object. That object can be a function. As a reminder, this is JavaScript. Functions are objects. Functions have methods. Breathe. It can intercept any interaction that your code can do with that. It usually falls into about 8 possible categories. So the wrapper, it is, you can think of it as the latest step, although it's 10 years old, in JavaScript meta-programming, right? We have stuff like object keys, object get-on proprietary descriptors, object has prototype, or all these things. This is the next step. And they cannot be polyfilled. They have to be natively available on your runtime. There's no way to polyfill it. Fortunately, they showed up 10 years ago. They've been widespread for over 9 years, and they've been available in Node since Node 6. As a reminder, this month, we're releasing Node 24. They've been deemed baseline in browser for a very long time, so you can use them with confidence, unless you're still supporting IE, in which case, what are you doing? Right? You build a proxy like this, you use the new proxy constructor, you pass it the original object, what we call the target, and you pass it another object that we call the handler. That object has what we call traps, which are methods with very well-defined names for all the possible interactions you want to intercept. And you got 2 specific interactions. The most common ones are get and set for accessing properties. If you're proxying on a function, you would use apply and construct for intercepting the call operations or the new operator on it. And you can do anything, absolutely anything. This is JavaScript. You can do whatever you want instead of the original behavior, but when you do need the original behavior, you would use the reflect namespace that has methods with the exact same names and signatures as your traps, and you can just forward it and get the original behavior. So here's a very dumb example. There's an object called conference. This is today's conference, and then there's a proxied conf, which is a proxy over that conference, right? So this is actually live code. And as you can see, I'm intercepting just the get trap, so the fact that you would access a property, right? This works on any property, regardless of whether it exists or not. So as you can see, here it goes. I'm proxying an access on name, and it does intercept and log that I'm reading name of that thing, right? And I could say, okay, so proxied conf dot year, fine, and again, this works on anything, right? It doesn't need to exist beforehand. It's just like it is a property access, it is a get operation, it's going to trigger. And then you could do whatever. You could live create that foo method, a bit like the method missing in Ruby or equivalent in other languages. And so you can do a lot of really fun stuff, although whether what I find fun and what you find fun is the same thing is up for debate. But this is my talk, and if I say it's fun, it's fun. So demos, actual demos. I had to cut some of those demos. I hope that this is up to date the way I deployed it, otherwise I'm going to fast skip through a few of these to stay on time, but the entirety of it is online. Type-safe-ish object properties. For some reason, people from statically inclined languages, such as Java, just clutch their pearls when you use a property that is like a string and you start writing a number in it. There are actually valid use cases for it. After all, TypeScript lets you say this thing is like string or number, you know? And yes, that is sometimes a good idea. But let's say you want to be conservative about it, and you go like, no. When you're writing on a property, if that property exists and it has a type, you better be writing the same type. Otherwise, I'm actually going to throw in production, because this is runtime code, it's not just type-checking code, and I'm going to throw a wrench in your oh-so-precious AI demo. So as you can see, I'm intercepting the set trap, and if that property does exist, which is the in, I'm looking at the known type, and if that known type is not the type of the value that I'm passing, I am throwing. Otherwise, I'm delegating to this, right? So let's say, again, we have that object named dotJS. We're making it type safe-ish. And if I do try to write in name a number, and the original type is string, it will throw. It will throw a property name expects a string. If I create a new property, addition, it starts as number, now the reference type is number, and if I try to write a string, it's not gonna work, right? Whether that is a bit obsessive compulsive or not is up for debate again. I would go like, you know what I meant? You know? That's what we do, by the way. We used to joke, like the computer knows what you meant, like, oh, of course not, and then we have AI, and LLM, and it's like, what do you mean you don't know what I meant? You know, it's like, so here's a shout out, I'm gonna have a few shout out in that talk, to a really fun and absolutely useless in production. By the way, do not ever put that in production code. Library by Matthias Biner is a V8 core team committer extraordinaire at Google. And this is TPYO, which is a typo on the word typo. And yeah, this is so meta. And what it does is, as soon as you wrap an object with TPYO, you cannot possibly not find the property you're looking for, because if it doesn't exist, it's gonna find the closest one by Levenshtein distance. So this is actually hilarious, right? Because like, puss actually maps to push, fortunately enough. You know, maybe that's good for like government code where everything has to be in French. Or longer actually maps to length. And I did a version of this talk in the Netherlands, and length actually does map to length as well. Avril 3, which is today, does map to at. Right? So this actually maps to the fourth cell. Plop maps to pop, but it looks so much better. Plop. And shot doesn't map to shit. There is no shit method, right? Even if some Java guys say JavaScript is shit, but no, that maps to shift, right? So this actually does work, and if you try to compute in your head what war is going to look like, it looks like this. It looks like just like .js and .css at the end of this, right? So it's actually very funny, but oh my God, do I not want that in production code. So do that in the code base of people you don't like, right? Negative array indices, same cool trick. In a lot of languages, you can use negative array indices between the square brackets. Square brackets in JavaScript have a more global semantics at the object level. They're called indirect indexing operators. And no, either the property exists as such, you'll get it, or you'll get undefined. But we do have negative numbers on like slice and splice and at and all that. And we could do that. We could wrap those arrays, intercept the get for the read access, and say, oh, that's a negative number. Let's turn it into the matching positive number and just delegate. Same for the set. And it would work, right? You would have all the dot conferences, .js and so on. And 0, obviously, we haven't broken positive numbers. 0 does work, but -1 would be the last one, -2, the penultimate one. You can do that with .at and the parentheses, but this looks so much better. And because this is Paris, right, we could actually replace .scale with .monter à l'échelle. Oh la la, the Frenchness. And yes, monter à l'échelle, forget that translation. And this is, again, like a live playground that demonstrates, and that you can play with in the slides, that demonstrates this. And you've got links to the full implementation. You could use that for mini observables and have some sort of like cheap reactivity on top of it. So a lot of that is so that it types, actually. We could have an object where every mutation of that object, so setting a property, deleting a property, is recorded. And not necessarily recorded, but actually broadcasted to whatever subscribers happen. And so we could create the proxy over those objects with maybe a $subscribe method to register subscribers, and just delegate to the original behavior, but just like sends all the subscribers. This is a very naive implementation. It doesn't isolate failure. It does that synchronously. This is just so it fits in the slide. You get the idea. I intercept set, so I get a previous value and the new value, and then notify my subscribers, intercepting the delete operator, and same thing for deletion. I could do a couple more, and then my subscribe method would just be adding my subscribers to my subscriber set. And it actually works pretty well. If you look at this, so let's just modify name, and there you go, I'm logging. My first subscriber console debugs this, so I'm logging from dotJS to this. This conference is actually not just thumbs up, it is stellar. So let's just show it. It does have an after party, but we want to keep that a secret. So let's just like delete this. And if I log that prop log, I can see that my second subscriber did indeed get called and accumulate that into the prop log. So it's kind of cool, although this is a naive implementation. Sorry, yeah, I need to get out of that code editor and get back to my slides. And that's exactly how Vue.js 3 actually implements reactivity, right? With the new reactive thing, well, it's not new anymore, right? Vue.js 3 has been there for a while. But in Vue.js 2, this was based on property descriptors, which came with some performance penalty and also different ergonomics, depending on whether you wanted to modify a property, delete a property, and the fact that you had to do that in properties that were all declared to begin with. Most of that got relaxed in Vue.js 3 because they use proxies, right? It is faster, it is a lot more versatile. Proxies are awesome! So TTL refs, another cool example where basically I'm wrapping a function and you can only call that function for a given amount of time. There are multiple ways to do that. You could do that with proxy.revocable as well. But I chose to, you would get, when the proxy gets revoked, you would get like a very generic error, not very actionable, not really good DX. So I'm actually intercepting the apply and trap because I'm proxying on a function. So this intercepts the function call. Maybe I would want to intercept function call with the new operator as well, and then I would intercept the construct trap as well. And basically, at every call, I'm going to look whether I'm past the expiry time, which was defined at proxying time. And if it is, I'll throw a bit more of an actionable error, right? Like this function cannot be called anymore because TTL of so much milliseconds expired, instead of just type error, basically. And this works quite well, right? I'm just intercepting apply, checking this. So here's a live code again, which is not auto-run this time. So as you can see, I got a say hi function. I got a say hi fast, which is a say hi that I only have half a second to call. I'm calling it synchronously. I'm calling it 400 mils after that. And I'm calling in 500 and some milliseconds after that. And so the last one should throw, and indeed it does, right? So it's actually kind of cool. You could do that based on any heuristics, right? Amount of calls that you allow the function to go through, or just time, or whatever. It's actually pretty neat in terms of some form of rate limiting. You could do native debouncing or stuff like that. It could be kind of nice. Proxies are really aspect-oriented programming, right? If you're familiar with the AOP, which traditional languages mostly do to decorators, that's really what this is all about. We could do URL builders, right? DSLs, domain-specific languages. Let's say we want to be able to create a builder like that based on the domain and just like call whatever shit on top of this. Like that dog, you know, I have no idea what I'm doing. And just like call this, and all of these become segments of the URL. And at the end of it, we end up calling with the parentheses operator, possibly passing query string elements, and we would get this. So it's actually kind of easy to do. We just accumulate those parts. We're proxying on a local function, which is the function we'll end up calling, which will do the final building. And we're intercepting get and saying, oh, OK, just accumulating this in the parts and returning myself, and we're done. For internal consistency, we're also intercepting has, which is whatever looks into an object and sees whether the property is there. So that would be has on property, that would be the in operator, that would be a number of things like that. We don't technically need that for that proxy, but it's just so it's internally consistent. And then my build URL function just like grabs whatever query string elements you might have created, uses the URL search param system to make that into a clean URL, resets, so you can use that same builder again, and returns the string. And that does work. This is live code again. And if you go like builder by bacon and eggs, apparently this is continental breakfast today. And you do get that segment, and you can use like square brackets for non-identifier segments, like numbers or whatever. And this just works, right? This is actually very, very fun to play with. Like I could say, OK, let's just say yeah, categories and maybe brands 42. And I would have like order cheapest first, right? And you can see this just works. Right? It's kind of cool. You can write like cool DSLs on top of this and get some nice DX sometimes. And VCR would be sort of the same thing, where we sort of want to be able to do any sort of interaction with an object that is actually a mock for the actual object, and it would just record all those interactions, all those mutations, so any writing, any function call. And then we would replay those interactions on an actual object. Right? This is a facility that does exist in a number of standard libraries and languages. It is a bit hard to get right. You could use that for immutable transforms, for stuff like that. So we'd like to be able to do that kind of thing on that object. Apparently assuming there's a foo property, which is an object, which has a bar, which has a baz, which is a function, and so on and so forth. And then when we would run it on an object that conforms in shape, we should be able to just replay this and actually apply this. So the actual implementation is a bit hard. We're just going to go through, you can play with that after that. I absolutely do not expect you to get all of this in like 5 seconds at this time of the day after sugar stuff. But this actually works, as you can see. This is like an actual live implementation, and if I run it, I do get an object where foo bar name became hello, and foo bar cux was created 42, and the do, which changed the this kind, actually changed the kind and made it to uppercase, and so on and so forth. So this actually does work, which is kind of fun. That implementation is super naive. There are a lot of edge cases for this kind of thing, but that's something that Emmer.js is absolutely amazing at doing. Who here knows about Emmer.js? Yeah, it's decent. Should be 3 times that. Emmer.js is a wonderful library by Michel Verstraete, who's also the one behind Mobex, state manager, and it is incredible. It lets us write immutable changes, right? So derived objects, deep derived objects, using code that looks like it's mutable, which often, especially for deep structures, is a lot simpler to read and reason about than having to do all those nested manual spreads where it's very verbose and very error-prone, right? So instead of doing these, like, okay, let's spread the top array, and let's modify session 1 on the derived array with another spread, and so on and so forth, and this is actually a very simple case. You could just go like, okay, let's just wrap that into an Emmer produce, work on the draft, and do it as if we just mutated the object. And that's it. And it will replay that in an immutable way with copy on write, guaranteed. So it's actually pretty amazing. And this has like built-in React hook. It plays really nicely with use reducer. It plays really nicely with Redux. It's actually built-in Redux toolkit. And this is not React specific in any way. So you can actually use that with whatever your favorite framework is or state manager library is. And it's really, really, really great. And the code is interesting. So the key takeaways I have for you is ES proxies allow for next-gen metaprogramming. I love metaprogramming. I think it's really cool. It's a really good way to provide good DX, both for your internal stuff and for anything that is user-facing, like a library and API. You can use them for really like a ton of use cases. They're extremely fast. You have like a performance penalty that borders on 0. And it's a lot faster than object descriptors, by the way. So it's really, really fast. They're very flexible. They're natively available everywhere, really. You would have to go so far back in time to find a runtime that doesn't natively support them. So please go forth and make cool things with proxies. Thank you.